Hi everyone. UAV now is a very popular instrument to do the field research, but most of them use camera to take images and record videos and then process them. In this research, we use a UAV that carries a LiDAR system to measure sea surface elevation, that is, to measure the wave height. Thank you for watching this presentation during the VICCE 2020. My name is Cheng Ye. My advisor is Huang. I am a master graduated student from National Central University from Taiwan. This is the title, A UAV-RTK-Lidar System Measurement of Wave Energy Dissipation over a Sandy Beach and an ALGAL reef area. When waves propagate from outside the shoreline to inside, the total dissipation of waves comes from two parts. One, the breaking dissipation, and the second one is the frictional dissipation, which is on the top of the sea and which is on the bottom of the sea. Since the wave energy dissipation is a very significant factor that affects coastal hydrodynamics, coastline morphology, wave height transformation, and also the ecological system. So we need to quantify the wave energy dissipation. In tradition, we need to deploy several in-situ instruments to quantify this quantity. In this research, we would like to test to use a UAV-RTK LiDAR system to measure the wave height and to calculate the wave energy dissipation. And we will also like to test the system to measure the dissipation over the two locations, which is Sandy Beach area and the ALGAL reef area. This is the related research, waves breaking and the frictional dissipation, and also the calculation of wave energy dissipation. Once again, the total energy dissipation comes from the breaking dissipation and the frictional dissipation. This is the UAV we use in the field. It combines three parts. One, the GPS, it records the instantaneous locations of the UAV. And the AHRS, it records the attitude and the heading of the UAV. The last one is the LiDAR component. It records the range data from the UAV to the sea surface. We used an industrial computer to record the three components data. The advantage of using this UAV is high mobility, high accuracy, and it is very quick response in the field, and it is low cost. Furthermore, with the autopiloting system, we can navigate the UAV to the specific waypoint in the field very easily. Here shows the videos. This is the UAV hovering above the sea surface, and this is about 6 to 8 meters high, and it stops over the locations, and the LiDAR system measures the sea surface elevation and also measure the wave height. Is the video of autopiloting. However, we manually take off the UAV and land it because for safety reasons. And after takeoff, the autopiloting system controls the UAV. So we can navigate the UAV to the specific waypoint. As you can see, this UAV now was flowing away from the coastline. It's about 200 meters away, 300 meters away. And it's still flying. Almost stops to the waypoint. Almost there. The UAV is about 6 meters high above the sea surface elevation. Okay, so the UAV now stops over here and starts hovering. The LiDAR system also starts measuring the waves. So, what does the LiDAR data of waves looks like? Here show the 3D plotting of the LiDAR data of the waves. As you can see, this transaction is very clear. You can see a very clear wave shapes over here. The return rates of the sea and the algal reef and the sandy beach area of the LiDAR is different. We shows the results of the mean return rates of this area is 4%, 57%, and 50%. The sea surface area, the return rate of it is very low, it's only 4%. We use this equation to calculate the dissipation of waves. D equals the minus delta F, which is the variance between the energy flux on the two locations on the sea, and over the delta X, which is the distance between the two locations, times the cosine theta. Cosine theta is the wave direction, which is defined by the series of aerial images captured by the NORAD UAV in the field. So, the UAV-RTK-Lidar system measures two locations in one flight and calculates the variance of the energy flux, and then we can calculate the dissipation. Here shows the calculation of the waves breaking and the frictional dissipation. Note that nuclear roughness Kw, we defined it as 4 times sigma b. Sigma b is the single length standard deviation of the elevations. We use the UAV to scan the surface of the algal reef and the sandy beach area to calculate the roughness. We did 2 field experiments. One is in algal reef area on the day 255 in 2018. The other one is the sandy beach area on the day 254. You can see the picture of the algal reef. It is very coarse, and this is the surface of the sandy beach area, and it is very smooth. On the algal reef area, we set 2 waypoints. One is W1, which is on the outside area, and W2, which is in the inside. And we also deployed 2 pressure sensors on W1 and W2. However, the pressure sensor on W2 is failed. The UAV measured 2 locations in one flight. So after takeoff, the UAV go to the W1 location and then go to the W2 locations. 9 flights were conducted in 8 hours on the day, and a high tide was coverage. These are the comparisons between the 2 techniques from the UAV and the pressure sensors. As you can see, the comparison of tide is very great. The significant wave height is also very great, and also the energy, and we also compare the wave spectrum. However, this time is caused by the high wind speed condition. The UAV will shake a lot, so the variance is very high. These are the results of wave dissipation. In panel B, here shows the difference of the energy flux. W1 is outside, W2 is inside, and then we can calculate on the algal reef area on that day. The dissipation rates are within 5 watt-meters. We need to distinguish the wave conditions and then to calculate the dissipation of waves breaking and also the dissipation of frictional dissipation. So we use another UAV to capture the aerial images of the sea surface condition. These are breaking condition, non-breaking condition, and low tide condition. These are the index of the waves breaking on the algal reef area is 0.29. We use the UAV to scan the surface to measure the elevations. Shown here are the results of the topography of the algal reef. As you can see, it's very coarse, and the roughness is 0.19 meters, is 19 centimeters. And then we calculate the Kw as the 4 times 0.19. The results of the frictional dissipation shown here. In the coral reef area, the coefficient of the frictional dissipation is 0.0643 on the coral reef, and in the same location, which is in the algal reef area of the previous result, the coefficient is 0.0478. And in this experiment, we use the UAV to measure the coefficient is 0.0471. We also calculated the dissipation of frictional counts. The total dissipation is about 70% to 100%. It shows that in the algal reef area, the dissipation of friction dominates this area. In the sandy beach area, we set 3 waypoints, W1, W2, and W3. The UAV measured 2 points in one flight. So on the first flight, the UAV measured W1, W2, second flight W2 and W3. We also put pressure sensors, and also these pressure sensors failed. These are the comparison between the two techniques, and this is the time comparison, and all of the comparisons very well. These are the results of the dissipation of wave energy on the sandy beach area. It is within 15 watt meters. We also distinguish the wave conditions: breaking, non-breaking, and low tide. The index of the wave breaking on the sandy beach area is 0.3. And we also use the UAV to measure the surface of the sandy beach. So as you can see, the surface here is very smooth and the roughness is 5 centimeters. These are the results of the frictional coefficient. The sandy beach area, the coefficient is 0.0139, which is far lower than the ALGAL reef area. And the result shows that in this area, the dissipation of waves breaking counts about 62% to 77% of the total dissipation. So the waves dissipation count dominates this area. The characteristics between the two areas shown here: 90 centimeters is the bottom roughness of the ALGAL reef and 5 centimeters is the sandy beach. The bottom roughness is much rougher on the ALGAL reef, so the frictional dissipation dominates over here. And here in sandy beach area is very smooth. The waves breaking dominates here. The conclusion: we use an EIGHT-ROTOR UAV to measure sea surface elevation and then calculate the wave heights and then to calculate the dissipation of waves and waves. We also use the equations to calculate the waves dissipation and also the dissipation of frictional. And we calculate that the coefficient is 0.0471, which is larger than the sandy beach area. So we can use the UAV to calculate the dissipation of waves and also to find out which effects dominates the area. Thank you for watching. Hope you enjoyed it.